Thank you everyone for sticking around. My name is Muhammad Ali, and I'm an analytics solutions architect at AWS. Today I will be talking about observability and how you can use AWS's managed open source offering to build an observability platform. We'll start by describing the importance of observability to an organization, and then I'll share a reference architecture, and we'll see that reference architecture at work in a demo. And then at the last, I'll share with you some resources that you can sort of use to learn more about observability and these platforms. So if you asked a business leader in your organization about what they want the company to focus on, right? So these things can be categorized into three buckets. Either they want you to, acquire new customers or delight the existing ones, which is improving the top line. Or they want you to be efficient in what you're doing, either operations or financials. That's improving the bottom line. Or third would be reducing the risk. That is complying to a regulation or improving business continuity. Now, if you see what IT developers do in the day-to-day activities, we build the applications. And those applications create those new user experiences that delight our customers. And to run these application or experiences, we automate our infrastructure, right? And then we monitor them and we troubleshoot them in the case of a failure. And then we get those learnings and build resilient architectures. Successful companies are the ones that let their developer focus more on business outcomes or the activities that add value to the business, direct value, and less on the operations. And as you see that, while we are running these applications, failures happen, and that gives us the chance to learn more about our application. And as our CTO, Dr. Warren Vogel says, everything fails all the time. So it's your ability to react to those failures is what determines how much time you're going to spend on operations versus the time you're going to spend on building applications. Now, to operate any system efficiently, you must know how it behaves in different situations. And that's what observability enables. Basically, it promises visibility into your application so you can understand them better and troubleshoot in the event of a failure. And with that knowledge, you're able to improve the resilience of your application by building resilient architecture and essentially improving the customer experience. So observability has its roots in control theory. It essentially says a system is observable if you can interpret its internal states by just looking at its external outputs, which means, for example, in the case of a factory with large machines, pressure, heat, noise, these are the signals that might tell you how machines are behaving internally. Now, when you talk about applications, observability helps you collect and analyze signals from your applications and associated infrastructure so that you can understand the internal states and be alerted to in real time. And then it gives you tools to troubleshoot and resolve issues quickly. Essentially, you spend less time in debugging and more time in building. Now, observability delivers these promises by, as I said, collecting the data and turning them into insights. So what are the signals we were talking about? So as the industry has matured, there is a general consensus what signals make a robust observability solution. Now, capturing metrics, which is time-bound measurements of your application, resource utilization, help you detect and get alerted to if your user experience is degrading. For example, high latency in your microservices could be a signal that can intimate you to start an investigation before your user complains about it. Now, second is traces. Traces track end-to-end request processing of a user functionality, call it checkout in an e-commerce application, right? Traces are critical to pinpoint the error in a complex distributed architecture, so you can focus on the components that are degrading the function. And then when you know which function has a problem, log will tell you the events happening in the application, so you can find the root cause. Combining these three signals is what makes a robust observability system. Now, as I said, essentially, your workflow of detection, investigation, and remediation is optimized, and the time you spend is shrunk when you have an observability system in place. Now, the importance of observability is magnified when you move from a monolithic traditional architecture to a service-oriented or microservice-oriented architecture. Now, there are many, many moving parts in such architectures, which means it could take more time to investigate. But with observability in place, you can adopt these microservices style architecture, but yet stay on top of the complexity because you have the visibility into what is happening in your applications. Now, on the screen is a reference architecture of an observability solution that uses Amazon OpenSearch service and Amazon Managed Prometheus service as its central store to store this data. Now, the architecture follows a typical data pipeline for collecting these three types of signals that we talk about. Now, application to the left are the producer of these signals that we want to monitor. Application could be anything, your internal application, your external facing applications. Now, we want to observe these applications. These are the applications that produce these signals. And to understand how they're interacting, we instrument them with OpenTelemetry SDKs that help track and collect the trace data. Logs and metrics can also be collected by using various open source tools. FluentBit and Beats are popular example here. Now, these signals are aggregated, so the collectors is what collects the signal and pushes the data forward to what is called an aggregation layer. Now, the aggregator tools are designed to offer buffering. You could potentially send the data from these collectors directly to the stores, but you could have hundreds of microservices that could overwhelm your data stores. And what if your data store was under maintenance? So that's why you need that buffering layer before you write the data to the final store. Now, OpenSearch, Data Pepper, Logstash, Kinesis Firehose, and Amazon S3 are very popular for aggregation. Eventually, the logs and traces are written to Amazon OpenSearch service, and metrics are written to Amazon Managed Service for Prometheus. Then we use OpenSearch Dashboard and Amazon Managed Grafana to visualize or create alerts on these signals. Now, today, I have built a demo that uses these three open source tools for instrumentation and data collection. We use OpenTelemetry to collect the trace data and metrics data, and FluentBit is used for collecting the logs. Now, Data Prepper is an open source tool by OpenSearch project that is created to convert the signals that are coming from those collectors, such as FluentBit or OpenTelemetry, and then convert them into shape that can be visualized, that can be stored and visualized in OpenSearch. Now, we have just announced 4 days ago OpenSearch ingestion service. That is not, I don't have a slide for it, but we've just announced 3 days ago OpenSearch ingestion service, which is basically makes this OpenSearch Data Prepper as a managed offering. Now, I'll take a moment to highlight the importance of OpenTelemetry here. It is the second most popular project after Kubernetes only. It offers vendor-agnostic SDK and libraries to instrument application. It supports multiple languages, which means you could employ polyglot microservices architecture and still use OpenTelemetry as a standard tool for collecting your traces and metrics. And due to its popularity, many observability and monitoring tools offer compatibility, so you can move from one vendor to the other. Now, AWS offers distribution of this OpenTelemetry open source project. It's called AWS Distro for OpenTelemetry. The distribution offers additional capabilities on top of the open source one, so that you can collect the signals from your applications running in AWS and send them to AWS native services such as AWS X-Ray, Amazon CloudWatch, or Amazon Managed Service or Prometheus. Now let's switch to a demo and I'll show you how the observability sort of platform will work. All right. Okay, so let me describe the application. In the previous example or previous session, you saw Rio describe how Kubernetes can be deployed, and we've used a similar sort of technique to deploy this. I've got 6 microservices here that make up my e-commerce application. I'm collecting logs from Fluentbit. It is capturing the logs and forwarding it to Data Prepper, which writes it to OpenSearch. Now, AWS Distro for OpenTelemetry is up there collecting metrics and traces. The data for metrics gets written to Managed Service for Prometheus, where I use Managed Grafana to visualize. Whereas the data for traces goes to Data Prepper, which converts these traces into data that can be written to OpenSearch and visualized by OpenSearch's observability plugin. Now, my application is a typical shopping cart. You select the products, you add them to a cart, and then you do a checkout. So that's just a view of what the application looks like. Now, as I said, I'm using Managed Grafana service for visualization. What I've done is I've built a dashboard on my metrics data coming from these containers running in EKS. So you can see memory, CPU, and other metrics visualized here. But what is important here is this panel where the CPU usage is visualized. This panel monitors CPU usage for payment and order service. What I've done for this demo is I've created a couple of alerts. So one is I'm monitoring the CPU, and the rule says if the CPU usage goes beyond a certain level and stays there for a minute, intimate me or send me a message on my Slack channel. So that's the configuration that is there in Grafana. Now, second type of signal were traces, and third were logs. So on logs, we can also monitor for events that are, that indicate problems. So here we're jumping into OpenSearch dashboard, and I'm jumping to alerting plugin in OpenSearch dashboard. OpenSearch is receiving our logs. Here we have created what is called monitor. Monitor are basically rules that run continuously and check your logs. So what are the rules that I've configured here? I'm saying index sample app logs, keep monitoring it, right? And if you see, monitor this app index log, and if you see an error text in the log line, and the count of such log lines is more than 1, send me an alert into my SRE channel. And that's the configuration for Slack notification. You can capture data from the alerts and send it to your Slack channel. Now I'm going to create some traffic. There's already a bug that I've put in place in one of the microservices. So we'll see error going in the logs, and we should be alerted to. So as I make some transaction, there will be some problems. You can see the CPU usage going up in Managed Grafana, and there should be some alerts in my Slack channel. So here's the message from OpenSearch, which says, I found some log lines that has errors. But for this particular demo, I'm just going to keep continuing generating the traffic so I can see a message from Managed Grafana as well. As you can see, the CPU usage keeps going high, breaches the threshold, stays there for a minute, and I get an alert. Now, this alert message has a link to a dashboard, which points to my observability plugin in Amazon OpenSearch service. So I'll just jump to that. Now, what I've done is I've pre-configured this plugin to include the microservices that make up my application. So you can see all these traces, the checkout operation, the pay order operation, create order, all of these are coming from OpenTelemetry. And they're visualized here in a single page. And to the right, you will see that it's saying there are 99% error in one of the trace group, which is checkout. Now that's my problem. That's an indication that I need to investigate further. So I'll drill down to see what I can find. So I click that. Now here, I'm just focused on checkout operation. To the bottom left, you're going to see an application composition graph, which shows heat map based on latency, error rate, and throughput. You could see inventory is slow, but latency is not my issue. My errors are my issue. So I'll go to error, application composition, see the error. I can see 3 of the microservices having problem. So that tells me I don't have to look everywhere. I just might have to look just 3 microservices. So I'll drill down further and see individual action of a user. Here, these are all the traces. These are all the user requests. As I click that, because OpenTelemetry is tracking all the traces, I am able to visualize, and this comes out of the box. You don't have to build that. It just comes out of the box. You can see the payment checkout is potentially having some issues. So what I'll do is now I know, there is a potential problem in my payment service. I might look at in different ways, tabular structure and all of that. But all I'll do is I'll take the trace ID of this particular request, which I know has failed, and then I'll search my logs. And now that I'm correlating it with my logs. So I'll go to my Discover panel in OpenSearch. This is all OpenSearch dashboard. As I pasted it, it pulls out the line that says service is not available, payment service Python on line 77 is having some issue. Now I have drilled down to exact line in my code which I need to look at. But because it's bug that is created by me, I know how to fix it. So I'm going to quickly go to my IDE and check out my payment service file, fix it, and redeploy it. So as I redeploy, I'll create more traffic, and my error should start going down. You can see it's 75%. Now it's going to 42%. As I continue refreshing it, it keeps going down. And I'll just check last 3 minutes, and the errors are all gone. Now what we were able to do is we were able to detect an error. We were able to troubleshoot. We were able to fix and see the errors are gone. And my application composition looks good also. Can we switch back to our slide? So what we just saw was basically we reduced the time that we spend on troubleshooting. We're good to go back to the slide mode. Perfect. Awesome. So that is the promise of observability, having you do all of these things much faster than you used to. Now, as I said, metrics, logs, and traces are foundational signals that will help you build that robust system. We use Amazon Managed Prometheus and Amazon OpenSearch Service to retain this data, to store this data. And it helped us sort of build this observability platform using these managed services. And managed services help you operate these open source tools without having you to do all the heavy lifting of configuring these open source software. Now, I'll give you a couple of QR codes here. One is for a course for knowing more about observability, and the second is a demo workshop which you can follow the instruction and build the same thing that I just showed you. So thank you for attending this session. I hope you enjoyed and learned a few things. I certainly enjoyed presenting it to you. Please help us by providing the feedback through a survey. Thank you again, and have a good rest of the day.